Hi guys, this is lecture 4.3, vertical and horizontal asymptotes. Recall that a rational function has the form f of x equals to p of x over q of x. The function f of x will have a vertical asymptote at c if q of c is equal to 0, provided that p of c does not equal to 0. Let's take a look at example 1 from your learning resources. Determine any vertical asymptote of the function f of x equals x over x squared plus x minus 6, and describe the behavior of the graph of the function for values of x near the asymptotes. First, what we have to do is determine the value of x for which f of x will be undefined. Therefore, we have to make q of x, which is the denominator of f of x, be equal to 0. Therefore, we have x squared plus x minus 6 equal to 0. And when we solve by factoring, we get x is equal to negative 3 or x is equal to 2. Now we have to check if these x values will make the numerator 0, because if it does, then we don't have a vertical asymptote at that specific point. And neither of these values at x is the numerator 0, so both of these values are given vertical asymptotes. So the equation of the vertical asymptotes are x equals to negative 3 and x is equal to 2. In order to determine the behavior of the graph near the asymptotes, let's draw a chart. Now what we have to do is determine the intervals. As you can see, we have 4 intervals as x is approaching negative 3 from the left side, x is approaching negative 3 from the right side, x is approaching 2 from the left side, and x is approaching 2 from the right side. Now what we have to do is determine the behavior of x plus 3, and x minus 2. So let's take the first one. X approaches negative 3 from the left side. The value of x will be less than 0. The value of x plus 3 will also be less than 0. And the value of x minus 2 will be less than 0, sorry. So we got a negative number, and another negative number. And when we have to determine the sign of f of x, we simply do it in the order that was given in the original equation. So we got a negative divided by a negative that times another negative. So we got, in total, a negative value. Therefore, f of x will be a negative value. And we do this for all of the intervals of x. After we do this, we can map out our graph. So when x is approaching negative 3 from the left side, we got a negative value. When x is approaching negative 3 from the right side, we got a positive value, so something like this. When x is approaching 2 from the left side, we also got a negative value. And when x is approaching 2 from the right side, we got a positive value. And this is what the graph looks like. Vertical asymptotes and infinite limits. The graph of f of x has a vertical asymptote x is equal to c if one of the following infinite limit statement is true. First, we got the limit as x approaches c from the left side of f of x equals to the positive infinity. Also, we have limit as x approaches c from the left side of f of x equals to negative infinity. We also have limit as x approaches c from the right side of f of x equals to positive infinity, and limit as x approaches c from the right side of f of x equals to negative infinity. Furthermore, we have the reciprocal function and limits at infinity. Limit as x approaches positive infinity of 1 over x is equal to 0. You can think of this as 1 over a very, very, very large number. So the limit of that will be close to 0. Not exactly 0, but very close to 0. So we just say it's equal to 0. And the limit as x approaches negative infinity of 1 over x is 0. So we get 1 over a very, very large negative number that will actually give us a negative number that's very, very close to 0. So we also say that the limit as x approaches negative infinity of 1 over x is equal to 0. And that's the end of this lecture. Thank you guys for watching.